Welcome to the channel Maths for Graduates. Today we will see the proof of Cauchy's residue theorem. So let's start. A statement of the theorem is, let C be a simple closed contour described in a positive sense, and if a function f of z is analytic inside on C except for finite number of singular points, that means f of z has finite number of singular points inside this contour C, okay, and except those points f of z is analytic inside and on C, okay. Suppose jk are singular points. Here k is running from 1 to n, okay, that means we have n singular point inside C, okay. Then integration of function f of z in C, this equals to 2 pi iota summation k is running from 1 to n residue of function f of z at point zk, okay. So this is Cauchy's residue theorem. Now let me picture as the situation here. Suppose this is x axis and this is y axis, okay, and we have some simple contour C here, okay, and inside this contour C there are finite number of singular points, okay, and those singular points are z1, z2, z3 and so on zn, okay. Since there are finite number of singular points, that means we can isolate these points with some circle, okay. Suppose circle is C1 and for this singular point Z2 circle is C2, and for this singular point Z3 circle is C3, and for this single point Zn circle is Zn, okay, okay. Now what I am going to do here, I am going to make a cut and make this contour C multiply connected contour, okay. So I am going to make a cut here and here also, here and here, okay, and I am going to make connection, okay. Now let's make a direction of this new contour. So this is the direction anti-clockwise, okay. Now in this contour, in what contour? In contour C, C1, C2 and Cn, okay, the function f of z is analytic. Why so? Because we have taken out those singular points from contour C, okay. Since function f of z is analytic inside this new contour, that means integration of function f of z inside this contour will be 0, okay. So we have integration of function f of z C plus integration of function f of z in C1 plus integration of function f of z in C2 and so on integration of function f of z Cn, this will be 0, okay, okay. I hope everything is clear to you till now. Now what I am going to do here, I am going to reverse the direction of small circles, okay. See, now let's make the direction of small circles in anti-clockwise. Okay. On doing so, this sign changes. Here this sign changes. So we have here negative sign and negative sign. Okay. Now we can write this integral as integration of function f of z dz. This will be integration of function f of z dz in C1 plus integration of function f of z dz in C2 and so on, integration of function f of z dz in Cn. Okay. Alright. Now if you remember the definition of residue, we know that residue of function f of z at point zk, this equals to 1 upon 2 pi iota integration in contour ck f of z dz. Okay. This is the definition of residue. So from here we get integration of f of z dz, this equals to 2 pi iota residue of function f of z point zk. Okay. Now utilizing this formula, we can write the integrations in right hand side. Okay. So we have integration of function f of z dz, this equals to 2 pi iota residue of function f of z point z1 plus 2 pi iota residue at point z2 and so on, 2 pi iota residue of function fz at point zn. Okay. Now we can write this in summation form. We have 2 pi iota summation residue of function fz at point zk, and k is running from 1 to n. Okay. So this is the required formula. Now this completes the proof. Okay. Now let's see some questions based on this concept. So in this question we have to find the integral of this function inside the contour modulus of z equals to 3. Okay. This contour is nothing but a circle of radius 3. Okay. So let's find. We have a function here. Function is f of z over z minus 1 into z minus 2. Okay. And it is given that function f of z is sine pi z over 2 plus cos pi z over 2 and whole z minus 1 z minus 2. Okay. Now suppose this function is g of z. Okay. Suppose this function is g of z. Okay. Now singularity of this function g of z is z equals to 1 and 2. Okay. So these 2 points are singularities for this function g of z. Okay. Now let's draw the contour. This is x, this is y, and circle of radius 3. So this is directed along positive direction, so it will be anti-clockwise. This circle is modulus of z equals to 3. Okay. So this point is 3. Suppose this point is 1, so it will be z equals to 1, and suppose if this point is 2, then it will be z equals to 2. Okay. So we can see here these two singularities are lying inside the contour. Okay. So from Cauchy's residue theorem, integration of f of z over z minus 1 into z minus 2 inside this contour C, it will be 2 pi iota into residue of function g of z at point z equals to 1 plus residue of function g of z at point z equals to 2. Okay. So now we have to find what? We have to find residues at those 2 points. Okay. So let's find. So residue of function g of z over z equals to 1, this will be limit z tends towards 1, z minus 1, and g of z is sin pi z over 2 plus cos pi z over 2 over z minus 1 into z minus 2. We can see here this factor z minus 1 cancels out. Now on putting limit, it will be 1 plus 0 over minus 1, and this equals to minus 1. Okay. So we have residue for function g of z at z equals to 1, this equals to minus 1. Okay. Now let's find residue at point z equals to 2. Okay. So residue for function g of z at point z equals to 2. This will be limit z tends towards 2, z minus 2, g of z is sin pi z over 2 plus cos pi z over 2 over z minus 1, z minus 2. Okay. Now we can see here this factor z minus 2 cancels out. So now we are left with, on putting limit, we will get 0 plus minus 1 over 1. Okay. So this equals to minus 1. So we have residue at point z equals to 2 is again minus 1. Okay. Now putting these two values here. Okay. So on putting the values of residue, we get the required integral. Okay. So integration of function f of z over z minus 1 into z minus 2 dz, this equals to 2 pi iota, residues are minus 1, and this will be equals to minus 4 pi iota. Okay. So we can see here option D is correct. Okay. Now this video ends here, and I have a quick announcement to make. Those students who are preparing for exams like CSR Net, GATE and other MSc Intense examination can buy our complex analysis handwritten notes for a very reasonable price for only ₹50. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.